Find the third derivative, f triple prime of x, for the function f of x equals the square root of 2x squared plus 1. Then evaluate f triple prime of 2. So f of x here is the square root of an entire expression, 2x squared plus 1. The first thing we'll want to do is rewrite the square root as first power, second root, 1/2 power, so we can see how to take our first derivative. F prime of x will be a power rule first. Bring the power down. Leave the inside alone. Subtract 1 from the power, I'll call that 2/2, and then multiply by the derivative of the inside, which is a 4x. Let's multiply the constants. We have a 1/2 and a 4. Multiplying those, that gives us 4/2 or 2. I will put the x there with that. And then I have the 2x squared plus 1 to the 1 minus 2 negative 1/2 power. Now, we have the option of leaving that in the numerator and having a product rule, or moving it to the denominator and having a quotient rule. The advantage of moving it to the denominator is it'll be a positive exponent. And there's the two forms that you could have, the product rule or the quotient rule. I'll just take it from the quotient rule. So the second derivative will be the derivative of the numerator, that's a 2, times the denominator left alone, 2x squared plus 1 to the 1/2 power, minus the numerator left alone, 2x, times the derivative of the denominator. We'll bring the 1/2 down, leave the inside alone, 2x squared plus 1. We will subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside, which will be a 4x. All this over the denominator squared. Now in the numerator, I'm going to leave the first term alone because I will be able to factor out powers of 2x squared plus 1. I have that in both the first and second terms. The second term, I have a negative 2, a 1/2, and a 4 for the constants. Negative 2 times 1/2 is negative 1, times the 4 will be a negative 4. I have an x and an x squared. And I have the powers of 2x squared plus 1 here to be 1/2 minus 2/2, 1 minus 2, negative 1/2. All this is over 2x squared plus 1 to the 1/2 to the 2. We multiply the exponents. 1/2 times 2 is 2/2, or 1 power. Now in the numerator, we're going to want to factor this enough so that we can take the third derivative. There's a common factor of a 2, but I'm going to leave that in. I'm going to factor out only what can cancel with the denominator, and that will be powers of 2x squared plus 1. Now in the two terms in the numerator, I have 2x squared plus 1 to the 1/2, and I have a 2x squared plus 1 to the negative 1/2. I can factor out the lower of the two, and that will be the negative 1/2. Now when you factor out a negative exponent, you're subtracting whatever you're factoring. You're dividing. And subtracting a negative exponent is equivalent to adding that exponent. So when I factor out a negative 1/2, I'm going to be adding 1/2 to the remaining powers. So what I have is a 2 times, now this term here, we're going to add 1/2 to that. 1/2 plus 1/2 is 2/2 or 1. And I will be left with a 2x squared plus 1 to the first power. Now in the second term, I'm completely factoring that out, so I'll just have a minus 4x squared. And all of this is divided by 2x squared plus 1 to the first power. Now we're looking to cancel the 2x squared plus 1s, or in some way combine them. And it turns out they don't cancel here, since this is actually a negative exponent that factored, but rather it moves down to the denominator to join the other one. but that still will help simplify it. So I will have my second derivative equals 2. I'm going to be moving the 2x squared plus 1 to the negative 1/2 to the denominator, so I will have a 2x squared plus 1 to the positive 1/2, and I have that 2x squared plus 1 that's to the first power, which I'm going to call 2/2 now because I'm about to combine those and you add their exponents. In the numerator, I'm going to distribute the 2 into here, so that will be a 4x squared plus 2, and then minus the 4x squared. We can combine like terms in the numerator. The 4x squareds actually will cancel, and I'll be left with just a 2. And in the denominator, we will have a 2x squared plus 1 to the 1 plus 2, add the exponents, 3/2 power. Now what this means here is our second derivative gave us a constant over a function of x, and that means our next derivative actually will not be a quotient rule, but rather we can rewrite this by bringing this to the numerator. You don't want to use the quotient rule when you have a constant in the numerator. You bring the function from the denominator up as a negative exponent, and we now just do a power rule on that. So our third derivative is actually simpler than our second derivative was. Sometimes functions become a little more simpler in form after one of its derivatives, and that certainly happened here. Our third derivative will be, 2 just comes along, we'll bring the power down, a negative 3/2, leave the inside alone, 2x squared plus 1. We're going to subtract 1 from the power, so I will call that 2/2, and then we'll multiply by the derivative of the inside to complete the chain rule. Now we're going to put all the constants together. Everything's multiplied here, so I'm going to have a 2 times a negative 3/2 times a 4. I'll just write them for now. And then there's also an x here that will move to the front with those. And then we have the 2x squared plus 1 to the minus 3 minus 2 minus 5/2. Now in multiplying the constants, the 2 in the numerator and the denominator can cancel each other, so I really just have a negative 3 times a 4, which is a negative 12x. And then I have that 2x squared plus 1 to the negative 5/2. Let's move that to the denominator to make that a positive exponent, and I end up with negative 12x over 2x squared plus 1 to the positive 5/2 power. There's our third derivative, f triple prime of x. The next thing to do is to evaluate f triple prime of 2. F triple prime of 2 will be plugging a 2 in for each of the x's. In the numerator, I will have negative 12 times a 2. And in the denominator, I will have 2 times 2 squared plus 1. And then all of that to the 5/2 power. So the numerator, negative 12 times 2, will be a negative 24. In the denominator, I will have 2 times 2 squared, which is a 4, plus 1 to the 5/2. Negative 24 divided by 2 times 4 is an 8, plus 1 to the 5/2. Say plus 1, of course, that's 9. And we have that raised to the 5/2. Now what 5/2 means is it means square root. Let's take the square root first, and then you can raise that to the 5th power. The square root of 9 is a 3, and we will have a 3 to the 5th. Now instead of raising 3 to the 5th, which will be kind of a big number, and then reducing later, let's reduce now, because 24 is divisible by, well, one of the 3's anyway, so we can take a 3 out from the 24 by taking a 3 out down here and just having 4 3's instead of 5 3's. So in the numerator we have a 8 with the negative, and then the denominator we have 3 to the 4th. Now 3 to the 4th, it can be broken up into 3 squared times 3 squared, or any two exponents that add to 4. But 3 squared is a 9, so it's negative 8 over 9 times 9. Of course, you have the option of just multiplying 3 times itself 4 times if you want to do it that way. But 9 times 9 is an 81, so I'm going to end up with a negative 8 divided by 81.